Welcome to our video solution to problem 3 from quiz 3. Here we are going to just be parametrizing some curves. This is not really an end in and of itself. Of course, we want to do all these parameterizations because we want to compute line integrals, which is going to require us to parametrize curves. So we have a few types that we have some pretty good idea how to handle: circles, ellipses, line segments, and then curves given by an explicit function. So that's what we're doing here. So for the first one, we're looking at a circle in the xz plane. So this is going to be in 3 space. But we don't have to worry about the y coordinate so much. We know at whatever the center is, it's okay, the y coordinate is 0. It's not going to change because you're in the xz plane. So when we go to write down our parameterization, we always like to call this R, the middle is just going to be a 0. We know that right off the bat. The y coordinate is 0, and because we're in the xz plane, and that's not going to change. Okay, next, the center of the circle is negative 3, 0, 5. Again, the 0 we already took care of, but I'm going to copy the center in here. Okay, next, I want to have a circle with radius 4. And to get a circle with radius 4, I'm going to take 4 times the cosine and 4 times the sine. Now, I actually want to go around this curve or the circle twice. So normally I would let t go between 0 and 2 pi. But if I do that, I only get to go around the circle once. So I make it 4 pi. That lets me go around the circle twice. So remember, these first pieces, that tells you where the center is. The constants in front of cosine and sine, that tells you the radius. And the cosine and sine, that's what's going to build our circle. Okay, number B. Yeah, B's a number. Let's see, we want the left half of an ellipse. Okay, so it's going to be an ellipse. We'll deal with the left half later. It's in the xy plane. The center is at 2, 4, so we could just treat this as a two-dimensional vector function. So we'll have r of t equals, and let's see here. So again, the center is at 2, 4, so we just start there with 2 and a 4. It's an ellipse, so it's almost a circle. So we get to put in our cosine of t and our sine of t. But there's going to be a different coefficient in front of each one. So the x radius here is 5. So I put a 5 there. And the y radius is 3. So I put a 3 here. And now we want to go around it. Oh, we want to go clockwise. So we have to play our little trick in order to let us go around it backward. Okay, well, our trick is you replace the t with a negative t. Okay, so that's gonna let us go around this thing in the reverse direction. There's other ways to do it, but this is a nice way to do it. And since we want to go around, well, let's see, it says the left half, right? We don't even want to go around one time. So what is our t going to go between? Well, we're going backward. So let's just draw a quick little picture here. We're going backward. So when t is 0, we would start here. But we only want the left half, right? We just want this piece around here. So as I go backward, I don't want to start until t gets to pi over 2. So I'm going to let t start at pi over 2. You might say, well, isn't pi over 2 up here? Well, remember, we put in these negatives, so it's actually going backward, right? This is actually negative pi over 2. Okay, so I get to pi over 2, and then I want to go around another pi, right? That would take me to 3 pi over 2. Cool. All right, so now we've got the left half of an ellipse. Beautiful. Next, we have a line segment. All right, this is one of the easier ones. So first, we can just start by writing down the domain for t. When we do our line segment, we can always set it up so that t goes between 0 and 1. That's just a cool property of parametrizing line segments. All right, it's not the only way you could do it, right? We could make our t go between lots of different stuff, but we can always do it this way. Okay, next, it's going to have 3 components, and we can start by just writing down the initial point. So -1, 0, 4. All right, then we ask, how much do I change the x coordinate by? Well, I go from -1 to 5, so I change it by 6, so I'm going to add 6t. And remember the reason we do this: when t is 0, this will go away and you'll just have the initial point. When t is 1, you'll end up with a 5, and you have the terminal point. We do that in each component. Let's see, from 0 to 3, we go up by 3t. Okay, and from 4 to 1, well, we go down by 3, so we'll go minus 3t. All right, there's our parametrization for the line segment. Finally, the one that causes people the most trouble, but is actually the easiest. We've written our x coordinate in terms of y, right? It's actually given by a function of y. So once I know the y, I can get the x using this formula. So I'll start by just putting in a t in the y coordinate, and then the x coordinate is just given by taking the y coordinate and plugging it into this formula. T squared plus t plus 1. And what are the values of t? Well, it's whatever the values of y were. -2, less than or equal to t, less than or equal to 3. And there we go.